We're going to take a look at math operations and making decisions using logic in JavaScript. Now, if you're someone who isn't a big fan of math, wasn't very good at math, don't stress out about this because the math that we're going to be doing is not actually particularly complicated. Most of the stuff that you're going to do for interactive stuff on the web is going to be basic arithmetic. And the only time you really have to go beyond that is if you were, say, programming a physics engine for a video game. So we're really just looking at arithmetic and how to solve problems using arithmetic today. I've got a blank CodePen example up here, and we're going to start doing stuff just in the console to keep things simple. So I've got the console open at the left here. Actually, let me switch my layout so that it's easier to see the console. There we go. Okay. So in JavaScript, I'm going to start with a number and set that to a variable, just a simple value. We'll call it value1 equals 10. Okay, I can log that value to the console. And as soon as CodePen refreshes, we should see the number 10 down there in the console. I can do arithmetic right here in console log, value1 plus 10, let's say. So what do I expect to see down there? I've taken my variable, which is value1, that has a value of 10. I've added 10 to it, so there is 20 down in the console. Now, something important to note is that the original value of value1 has not changed. If I try to log console log value1 again, right after I've added 10, notice that we first get, let me clear this so that it's fresh, and save it. And so we're going to see fresh console messages. It first logs 20 because the first thing I do is log value1 plus 10. And then it logs 10 after that because I'm logging value1 again by itself, not adding. So the original value of value1 has not changed. It's still 10 behind the scenes. I can use subtraction. So I'm going to see 0 and 10 down there in the console. I can use multiplication. That's going to give me 100. For the one that's multiplied, and then still 10 for the original value. And I can use division. So the basic math operators, basic arithmetic operators are kind of what you would expect: addition, subtraction, multiplication, and division. What's a case where this would come in handy? Let's say we are trying to calculate this is not a very exciting example, but maybe we'll make it make it a little more exciting. We're going to calculate the purchase price of a PlayStation 5 with Ohio State sales tax. So PlayStation 5, we'll say PS price is the name of our variable, and I believe that is currently $499.99. And the sales tax in Ohio, state sales tax, OH tax, is 5.75%. Might be different depending upon where you live in the state, but the state sales tax is 5.75%. So if I want to figure out what 5.75% of $499.99 is, I need to multiply it by 0.0575. I believe that's correct. 5.75%. Yeah. So I'm going to now let tax amount equals I don't want to type in these numbers, PS price, which again is $499.99, times OH tax. So let's now log tax amount to the console. So this is going to give us just how much tax are you paying, how much Ohio State sales tax are you paying when you purchase a PlayStation 5 in the state of Ohio. It's about $28.75, okay? We can figure out what the total purchase price would be. We could create another variable here, let total equals, what are we adding together? The PS price, the original price, plus the tax amount. So this is what you would expect to see when you actually ring it up at the register. Let's now log this total amount. 528.74. Why did that one go down? Huh, interesting. Okay, about the same. There are some weird sort of rounding things that will happen sometimes when you're doing multiplication with, we have several decimal places here, so that's probably why we got 0.749 one time and 0.739 the next time. Don't worry too much about that. We've figured out what 5.75% of $499.99 is. We've added that back to the original price, and that gives us our total. So just kind of a practical application of, you have basic math operators. What are you going to do with them inside of JavaScript? What's one thing you could do to an application you could use that for? So we've got our arithmetic operators, and there's one arithmetic operator that is unique that I'd like to go through an example for with you now. There's the remainder operator. And one case where remainder operators might come into play is, say, calculating a duration. This is actually right out of one of the examples that's been posted to the readings. But let's say we have a duration of I think I used the Barbie movie as an example from last year. The duration of the Barbie movie was 1 hour. Actually, let's double check what that is. Barbie movie duration, 1 hour and 54 minutes. Now, in JavaScript, it's going to be sort of difficult to treat a duration as hours and minutes. Formatted like this. The way that you and I are used to reading durations is seeing 1 hour followed by minutes. Sometimes it would look more like, maybe what we would normally see is something like this, 1:45, or sorry, is that what it was? 54. Got it backwards. 1:54. That's what we would normally see. You look up the running time of something and you would see like 1:54. But as soon as you add this colon in there, you're adding a symbol that's not a number. And so it becomes difficult to do math inside of JavaScript to figure out what is this duration in hours and minutes. So let's think instead about how many raw minutes is that? 1 hour, 60 minutes. Plus 54, so that's 114 minutes. That's the duration just in minutes of this movie. So how would we get hours? We want to divide duration by 60. Let's see what the result of that is. Let's just log that to the console. 1.9. So that's correct. I mean, it is a 1.9 hour movie, but again, that's not really the format that is human readable. That doesn't look like you wouldn't say to somebody, if they asked you how long a movie was, you wouldn't say 1.9 hours, right? You might say 1.5, but you wouldn't say 1.9. You would say 1 hour and 54 minutes, okay? So we still want to treat this hours number a little differently. Let's round it down. We want to get sort of the whole number. How many whole number hours are there in 114 minutes? So rounded hours equals hours, which is 1.9, and we're going to put math.round. Math.round is just a special math method inside of JavaScript. One of the more useful ones, so it's a good one to sort of keep in mind, and I use it in my examples a lot because it's sort of self-explanatory what it does. Math.round will round the number of hours down to the nearest whole number. So now if I look at the value of rounded hours instead, I get 2. Oh, that's right. It rounded up. So we have a different rounding method if you want to round down specifically. 1.9, of course, rounds up to 2. So math.floor will round down to the nearest whole number. Obviously, if you have a decimal that's 0.5 or above, usually you round up, and below 0.5, usually you round down. So you have to specify, regardless of what it is, I want you to round down because I want the nearest whole number. So we know it's 1 hour long. How do we figure out the minutes remaining? That's where our remainder operator comes into play. We're going to use this special symbol. It looks like a percent sign. We're going to say duration percent sign, which again is remainder, 60. So what the result of this will be is how many minutes are left. What's the remainder after you've divided 114 by 60? So let's look. We would expect to see 54, right? Because we know that there's 54 minutes after the first hour. Console.log minutes. There we go, 54. So I've calculated my rounded hours, which is just whole number hours, and I've calculated my minutes. I've turned 114 into 2 more useful values. 1 for 1 hour, and 54 for the number of minutes remaining. So how do I turn this now into something that looks like what I expect? I'm going to skip the second part of this here and go to string concatenation. String concatenation, we've just been doing arithmetic with numbers. And so a lot of those operators, plus, minus, divide, multiply, they behave like you'd expect. They add numbers, they subtract numbers. If you're using strings, what's going to happen is instead of, you can't subtract a string from another string, but you can add strings together. Remember, a string is just a value that is a word. So if I were to say, let my string equals hello, I've put this word in in quotation marks that tells JavaScript it's a string, and it's treated now like text characters instead of a value. If I log that to the console, I'll just see the word hello. There we go. There's my string in the console. So we sort of touched on this a little bit when we talked about different data types, numbers, strings. There's Boolean, which is true or false. If you try to add a number to a string, it will automatically treat that number like it's a string. It's going to lose its meaning as an actual digit, as an actual numerical value, and it's going to become just a text character. So I can create, let's say we'll call this variable formatted duration. This is going to be the duration that looks like what we want, 1:54. How do I get that? I'm going to add hours, which is the number 1, to, in quotation marks, a colon. As soon as I introduce a string into this equation, it's going to treat everything like a string. Hours plus colon, the number 1 in hours will now be a text character. It's no longer being treated like a value. So hours plus colon plus minutes, and actually I'm using the wrong hours here. I should be using rounded hours. So I'm setting this formatted duration with the colon in the middle to a variable, and if I log that variable, I'm seeing all kinds of errors because I'm changing things on the fly, but now if I log this new formatted duration variable, I should see 1:45 in the console. There we go. So this is a way to use pretty simple math and just sort of problem solving, logic, think your way through the problem. How do I turn, you sort of instinctually maybe understand that 114 minutes really means 1 hour and 54 minutes, but how do you turn that into something that looks like that when you're using arithmetic operators and string concatenation? Here's an example of how to do that. Now let's look at one more thing here in operators, which is assignment. Assignment operators, we've already looked at how if you add a number to another number, it doesn't change the original value. So let me clear out I'll keep duration because it's a useful number. If I were to say console.log duration plus 10, I'm going to see 124 down here in the console. And then if I log the value of duration again, it has not changed. The original value didn't change. There's 114 at the bottom because the very last thing I'm logging is what's the original value of duration. So what if I want to actually update that value? What if I want to accumulate and say add 10 to the original number? I'm going to say use an assignment operator, call duration plus equals 10. So that's sort of a shorthand way of saying, let me just show you what that would look like if I were to say duration equals duration plus 10. So it's the same, this here on line 3, duration plus equals 10 is the same as this, saying duration equals duration plus 10. Let's update that value of duration so it's the original value plus 10. It's just a shorter way to write that. So duration plus equals 10, log to the console, we've got 124. I can use minus equals, that's another assignment operator, so now it should be 104, 114 minus 10. And you can do that with any of the arithmetic operators. I could do divided by, which is going to give me, I think, 11.4, and I could do times equals. 10 equals 1,140. So those are assignment operators, a way to update the original value if you don't need it anymore. You can also use what's called, we've got the plus plus, which accumulates 1, it increments by 1. So I get 115 down there with plus plus, and I get, with minus minus, I can get 113. Those are good for doing things like counters. If you want to count how many times someone has clicked a button, you can just use plus plus to increment that value every time. In fact, why don't we try that out? Let's try, we're going to create a variable here called let count equals 0. So we're starting with the count of 0. We're going to create a button in JavaScript with an ID of counter button. Okay, so down here in the JavaScript, I need to go through my 3-step process of creating, let me save this so I don't lose my work here. I'm gonna go through that 3-step process of creating an interaction and adding an event listener. First thing I'm gonna do is make a variable for the button itself. So counter button equals document.getElement. And I'm going to use autocomplete as much as I can because I'm a terrible typist, so this will be a little less painful for you to watch when I use autocomplete. Set the value of that variable to be the button itself, the HTML element. I'm going to write a function, and what do I want to happen in this function? We'll call this count up. And what it's going to do is it's going to add, it's going to increment count by 1, count plus plus, and then we're going to log count to the console. So what I expect to see here is every time I click the button, the number in the console will go up by 1, just 0, 1, 2, 3, and so on and so forth. Now my third step, I've made the variable, I've written the function. My third step is to attach that event listener. So counter button dot add event listener. We need to tell it what kind of event are you listening for. I'm listening for a click, and what function should be run when you click on the button. We want to run count up when you click the button. Okay, so again, we don't see anything in the console right now because that function will only run when I click the button. If I click it once, it's going to immediately run this function which increments count by 1, so it goes up to 1, and then it will log that value. 1, 2, every time I click, it goes up by 1. If for some reason you needed to increase that value by more than 1, you would use the plus equals operator. So plus equals 5 would increase it by 5 every time. 5, 10, 15, 20. So depending upon the use case, plus plus might be the better choice. Plus equals as an assignment operator might be the better choice. All right, let's now move on to the logic part of this talk here. We've sort of done a little bit of logic already just by solving problems, but now we want to talk about how to make decisions in your code based upon certain values. Let's say, here's just sort of a really simple flow chart I put in this slide as a graphic of how you want to think through these kinds of conditions and how to make these decisions. Let's say we have a value called x, and we don't know what x is right now. It's possible that x changes every time you run your code. So we just want to know, is x greater than 0.5? If it is, you win. If it's not, you lose. How can we determine if you win or lose? We'll just put that message in the console as like just a little happy, you win, you lose down there in the console. So that's how we'll find out if this is working. We're going to write an if statement to evaluate this. An if statement, when we say conditional, we're talking about writing if statements. All right, so back here in my JavaScript, I'm going to delete, I'll leave the button there, but I'm going to delete this JavaScript here to clean things up. I'm going to make a value called x, and we'll set it initially to just 0. What I want to know is x greater than 0.5? If it is, I win. If it's not, I lose. So we start conditionals with the word if, and then in parentheses, you write what that condition is. If x is greater than 0.5, console.log, you win. Now you can already guess what's going to happen down here, right? X is 0, so nothing happens. Maybe you didn't guess that nothing would happen, but nothing happens because the only thing that we've told it to do so far in this condition is if it is greater than 0.5, do something. If it's less than 0.5, nothing will happen. So how do you make something happen if that initial condition is not met? You write an else. If it's not, so you don't have to say if x is less than 0.5, you can just say in any other condition. If it's not greater than 0.5, obviously it's going to be less than 0.5. So we're going to say else console.log you lose. And once it refreshes, there we go. There's my you lose down there. Because we know that x is 0, right? We already know that. So this runs, since it's less than 0, it's going to not run the first part in the if, it's going to run the part in the else. It's going to run the part that is sort of the catch-all, the like, if that first condition is not met, what do you want me to do? If we were to manually change x to 0.9, we expect to see now you win down there. What if we said x was a random number? Math.random will give you a random number between 0 and 1. So some sort of decimal point between the two. Every time JavaScript runs, this is going to be a different number. So let me clear this, get a fresh console down here, and I might have to refresh to get it to run again. There we go, you lose. Now I have no way right now of knowing exactly what the value of x is. I just know that it's not greater than 0.5. So why don't I put down here, after the if statement, everything in JavaScript runs from top to bottom. I'm going to say console.log x, just so I know what is the actual value of x. And that way I can confirm whether or not my if statement's working. So x is, actually let's put this before the if statement. That makes a little more sense. It'll be easier to read in the console. Okay, so let's clear this and refresh so it runs again. Okay, 0.51 and lots of other values after that. Is that greater than 0.5? Yes, therefore I win. If I refresh again, I'll get a new number. Math.random runs every time, gives us a new random number every time. It's still greater than 0.5. It still says you win. Let's try to get a less than here. There we go, 0.419. You lose. So sad. Okay, so we can change. There are other comparison operators besides greater than. We've got less than. So now that logic is reversed. It's going to say you win if it's less than 0.5. There we go, 0.14, you win. We can say if x is equal to. Notice I'm using 3 equal signs. That's a very important thing to do in JavaScript. You may find examples online where people only use 2 equal signs. Make sure you always use 3. It's kind of the newest convention, right? People are still maybe using 2 because they have old habits, but you should always be using 3 by default. Now this is very rarely going to be true because if I get a random number, it's very unlikely to be exactly 0.5. So maybe instead of, let's just put in hard code 0.5 in there, and now we know it's equal to 0.5. So look at the difference between my equal signs here. 1 equal sign is for assigning a value to a variable. 3 equal signs is for comparing, and that should only go inside of an if statement. If statements should always have, if you're checking for equality, you should always be using 3 equal signs there. You can also do greater than or equal to. Just means that it doesn't have to be more than 0.5. It can also be 0.5, and you can do less than or equal to. Those are the most common ones. There are a few other ways to play with if statements, but in terms of the comparison operators, let's actually do one more thing, which is what if you want to check for more than one condition? Let's say we have 2 numbers. Let y equals 0.9. Okay, so why don't we check to see, make sure that both of them are greater than 0.5. So I'm going to say if x is greater than, actually I should change x to 0.6, so it is actually greater than 0.5. How are we going to check for both? We're going to use the double ampersand. That just says condition 1 and condition 2 have to both be true in order for this if statement, in order for the first part of the if statement to run, the stuff that's inside these brackets here. So we know we've hard coded the numbers in, so of course we know that x and y are both greater than 0.5, so it's going to say you win. Since it's checking for both conditions, as soon as I make one of them less than 0.5, it's going to say you lose. They both have to be true. What if you only want to make sure one of them is true? Then you can use this is kind of a strange symbol. This double bar means or. This bar symbol is right above your return key. If you hold shift, if you don't hold shift, you'll get the slash. If you hold shift, you get the bar. So 2 bars means or. Either x or y can be greater than 0.5 in order for us to win in this situation. Okay, so that should cover it for the arithmetic operators and conditionals. And it's not so much the individual pieces, learning the syntax of these things, I don't think is what's difficult. It's more about getting used to the problem solving process and thinking through how to solve a problem. If someone says to you, how do I calculate sales tax on something? You have multiple values that you have to deal with there and different calculations you have to make. Someone asks you to format a duration a certain way, the way that we just did in this example. Think through how to solve that problem. Use, I guess you wouldn't need conditionals for that, but use these kind of flow charts if you do need to make decisions in your code. And until you sort of get more used to talking through those problems, internally, talk through them out loud too. Saying the problem out loud sometimes can help think through a way to get to the right solution. So these are the building blocks for writing programs, writing JavaScript that does interactions, that has interactivity built in. But in terms of writing a robust program, this is all very important stuff that will you'll start to become more comfortable with over time.